When we consider light, when we're looking for a model to describe its behaviour, we'll see that sometimes light can behave as a wave, and sometimes its behaviour is more the behaviour of a particle. And if we were to list these different behaviours under the two headings of wave and particle behaviour, we'd have this particular list. That is, typical behaviours of waves are refraction, diffraction, interference, that is reinforcement and annulment, and so on, and all the typical things that waves do. But there are a couple of behaviours that light displays which are definitely not wave behaviour. Examples of those are the photoelectric effect and Compton scattering. I'll just run through a very brief description of the photoelectric effect. If you have a target material and you then expose it to a light source, so the light source is coming into the target material, and if I represent the energy levels in that target material by these lines here, then the energy required to ionise an electron, which is at this lowest level here, all the way up to the top level there, must require at least that amount of energy in the energy difference between the ground state and the highest energy state. So if the light that's striking the target metal was, say, visible white light, it would be composed of various frequencies and wavelengths of light. So for example, in the visible spectrum, red light would be of low energy and the violet light would be of a high energy. Let's say in this example that the energy difference between the ground state and the highest energy state was equivalent to the energy of the green light. That would mean that the red, orange and yellow lights would not have enough energy to induce ionisation of that particular substance. However, the green, the blue and the violet light would. Now, if light behaved like a wave, if you just kept adding more and more and more red light to it, each of those little waves could add together, reinforce, interfere with each other until you had a lot of energy from that red. Now, that's if light behaved like a wave, in which case you could get the red light to ionise the atom. But we've observed that that actually does not happen. You must have a photon of the required energy for ionisation to occur. Now, this is known as the photoelectric effect. And this minimum amount of energy is called the work function. So if a photon with more energy, for example the blue photon, struck this target material, not only would it provide enough energy to overcome the work function, that is ionise the thing, the excess energy, because the photon can only give up all of its energy or none of its energy, so the excess energy provided to this electron would be shown as a kinetic energy as it left the material. Now that kinetic energy there will require a voltage to stop it moving, and that particular voltage is called the stopping voltage.